Atoms contain electrons, neutrons, and protons. These are the three subatomic particles that make up its structure. Draw one line to link each particle to its correct relative charge. So 3 lines, one from each box. So a quick recap on atomic structure. If you remember, an atom has a nucleus, and inside the nucleus you have 2 particles, positively charged protons, and the number of protons equals the atomic number. So this atom would have an atomic number of 3 protons. You have these other particles which weigh as much or have the same mass as a proton, which we say is a mass of 1. They're called neutrons, but they have no charge. And then in the shells or outside the atom, you have electrons, and electrons have a negative charge of 1. So protons have a positive charge of 1, and electrons have a negative charge of 1. And the number of protons in an atom always equals the number of electrons. So for every positive charge, there's a negative charge that neutralizes it or balances it out. So the overall charge of an atom is always 0 or neutral, but the charge of a nucleus is positive because it contains protons. So electrons have a charge of -1, protons have a charge of +1, and neutrons have a charge of 0. Which of the following is the relative mass of a proton? Well, the mass of an atom comes from the nucleus, and it comes from adding up the number of protons and neutrons, both which have a relative mass of 1, which means they weigh or have a mass which is equivalent to each other. So the mass of this atom would be 1, 2, 3, 4, 5, 6, 7. So the atomic mass would be 7, but the atomic number would be 1, 2, 3, number of protons. Electrons are roughly 2,000 times lighter than these particles in the middle, so they don't really contribute to an atom's mass. So this would be completely inaccurate. This would be for electrons. This would be irrelevant. You wouldn't have a mass of -1. A mass is a scalar value, not a vector value. You only put negatives and positives for vector values. So 1 is the correct answer. It's well worth remembering or committing to memory this table because it'll help you remember the key characteristics of an atom. Here's the charge, the relative charge. This means they have an equal and opposite charge, and the relative mass means these have the same mass, but this is roughly 2,000 times lighter. Argon is in group 0 of the periodic table. Identify, using the periodic table on the back cover of this paper, which of these elements is in the same period as argon. So I've copied the periodic table here. Remember, you have 2 sets of numbers. One set is drawn for you or written for you. These are called group numbers. So group 1, 2, you miss out all the transition metals. Group 3, 4, 5, 6, 7. Sometimes this is called 8, but on your one it's called 0. And you can think of it as a complete circle. So group numbers over here, they tell you the number of electrons on the outer shell of an atom. So outer shell only. But this number here, which I've added, which I've written in, you'd have to write in, just make sure that the 1 lines up with hydrogen, then 2 with lithium, 3 with sodium, and so on. These are called period numbers, and they tell you the number of shells. So the number of shells an atom has. So for example, if you took the 2 together, let's say group 1 and period 3, that tells me this atom has, let's draw the nucleus, 3 shells, and it has 1 electron on its outer shell. So that's how you use these numbers. Now back here, it says, identify using the periodic table which element is in the same period as argon. So argon, if we look, is over here. So we're looking for an element which is in this row over here. So which of these? So there's bromine, no, not bromine, iron, not iron, magnesium. Yes, there's magnesium over here, so that's the answer. Figure 1 shows the atomic number and mass number of 2 isotopes of argon. So we have argon-38 and argon-40. What this means is you have 38 particles in the nucleus of this argon atom and 40 particles in the nucleus of this argon atom. Isotopes you can think of in this way. Isotopes are atoms or from the same element. So you can see these are two different types of atom, but they're both argon atoms, same element, with a different atomic mass. And the reason why they have a different atomic mass isn't because of the number of protons. If you change the number of protons, you change the element itself. So the difference is due to the number of neutrons. Because if you remember, there's only two particles that make up the mass, protons and neutrons. So an isotope or isotopes are elements or atoms from the same element, so same type of element, but they have a different number of neutrons, not protons. They stay the same, so a different number of neutrons. So with this in mind, it says describe the structure of an atom of argon-38 and an atom of argon-40. So if you have to describe the structure, you have to talk about the number of protons, the number of neutrons, and the number of electrons, as well as where you'd find them. So we know protons and neutrons are found in the nucleus and electrons are found in shells. So let's have a look. So atomic number is 18, so we can see the atomic number is 18. That means that both these atoms, and I've drawn them here, argon 38 and 40, have 18 protons in their nucleus, both of them. That's why they're argon. If it was a different number, they wouldn't be argon. Then, atomic mass, we know, is the number of protons and the neutrons. So when you add those particles together in the nucleus, you get the atomic mass. So, to work out the atomic mass, to work out the number of neutrons, you just take the atomic mass, which is given to you in the table, so you can see that over here, the atomic mass, and you just subtract the atomic number, which is the number of protons. Because obviously, if the number of protons plus neutrons equals the atomic mass, then if you subtract the number of protons from the atomic mass, you're left with the number of neutrons. So atomic mass, take away atomic number, which is the number of protons, you have number of neutrons. So when we do that, we see that argon-38 has 20 neutrons and 40 has 22 neutrons. So this has 20 neutrons in its nucleus, this has 22 neutrons in its nucleus. And finally, the electrons. Well, the electrons in an atom always equal the number of protons, or the atomic number. By definition, the atomic number is the number of protons, but you should also know that it helps you, that the other piece of information you can understand from this is the number of electrons. So you'll have 18 electrons in the shells outside argon-38, and you'll have 18 electrons in the shells outside argon-40. So to get 3 marks, you'd say both have 18 protons in their nucleus. Remember, we have to say describing the structure is not just saying how many protons, but where they're found. And 18 electrons in their shells, so that's the same for both of them. Now we obviously have to talk about the difference. The most complex part is the number of neutrons. Argon-38 has 20 neutrons in its nucleus, make sure you say in the nucleus, whereas argon-40 has 22 neutrons. So that's how you answer that question.